in section 2.6, we're going to look at solving other types of equations. Some involve rational exponents or radicals or even absolute value. So the first few formulas that we can look at involve just some basic rules for solving these types of equations. So x to the a over b, if that is equal to c, you can get rid of that rational exponent by raising both sides of the equation to their reciprocal. So you end up with x is equal to c to the b over a. And the square root of x is equal to a. You can get rid of the radical by squaring both sides. So we're left with x is equal to a squared. And the same thing applies for a cube root. So a cube root of x is equal to a. Cube both sides and we get x equals a cubed. And then as long as a is greater than 0, the absolute value of x is equal to a, then x is going to equal positive or negative a. So this first example, we have the quantity x minus 1 to the 2/3 is equal to 4. And because this involves a rational exponent, we're going to try to get rid of that rational exponent because our goal is to isolate x. So we're going to raise each side to the 3/2 power. Okay, so what we're left with is x minus 1 on the left and 4 to the 3/2. Okay, so remember x to the a over b is the same thing as the bth root of x to the a, and a can go in one of two places. So it can go under the radical or it could go on the outside. Okay, so we're going to think about this as the square root of 4 raised to the 3rd. So square root of 4 raised to the 3rd is 2 to the 3rd, or 8. Okay, so equals 8. The only other thing that we have to consider is that upon raising both sides to the 3/2 power, we actually took the square root of both sides. And therefore, we would get positive or negative 8 on the right-hand side. And then add 1 to each side. And we get x equals 1 plus or minus 8. And therefore, x is equal to 1 plus 8, or 9, or 1 minus 8, which is negative 7. And we want to verify that our answers are correct. So let's go back to the original equation. Let's take one of these solutions at a time. So negative 7 minus 1, we're going to raise that to the 2/3 and see if this produces a 4. Okay, so negative 7 minus 1 is negative 8. Negative 8 to the 2/3. Well, that's the cube root of negative 8, which is negative 2. And negative 2 squared is definitely equal to 4. So negative 7 is a solution. And then we'll do the one more, the other. 9 minus 1. We're going to raise that to the 2/3. And we're going to see if the result is a 4. So 9 minus 1 is 8. 8 to the 2/3 is, let's see, the cube root of 8 is 2. 2 squared is 4. And that solution also works. Okay, let's take a look at another kind of problem. So a problem involving a square root, like the square root of x is equal to 4. I would square both sides, and we get x is equal to 16. Okay, so we're going to use a similar technique for this problem in that we will start by squaring both sides. And we have x minus 2 squared on the left, and then just 3x minus 8 on the right. And then at this point we want to just try to solve, we're trying to isolate x, and the first thing that I'll do is to square the binomial. So x minus 2 squared is x squared minus 4x plus 4, and is equal to 3x minus 8. And we notice now we have a quadratic equation, and so one thing that we could do is just move all terms to one side and try to factor or use quadratic formula. So we'll subtract 3x from each side, and we'll add 8 to both sides. And we're left with x squared minus 7x plus 12 is equal to 0. Okay, at this point we'll try to factor, and we need factors of 12 that add to give us negative 7. Okay, so negative 4 and negative 3. And then set each factor equal to 0. So if x minus 4 equals 0, x is 4. But if x minus 3 equals 0, then x is 3. Okay, lastly, we need to check our solutions because we could have an extraneous solution, meaning it does not work in the initial equation. We'll start with 4. 4 minus 2, and we want to see if that equals the square root of 3 times 4 minus 8. Okay, so 4 minus 2 is 2. And 3 times 4 is 12, 12 minus 8, and this becomes the square root of 4, and that is equal to one another, so 4 is a solution. And then we'll do this one more time, so 3 minus 2, does that equal the square root of 3 times 3 minus 8? Okay, so 3 minus 2 is 1. And does that equal the square root of 9 minus 8, or the square root of 1, which it does? So both of those are solutions to this equation. So another type of equation is an absolute value equation. And so if we have a more basic absolute value equation, like the absolute value of x is equal to 5, then it's pretty clear what the answer or answers are. So remember, absolute value is just the distance a number is from 0. And so in this case, x could be 5. That's 5 spaces from 0. But negative 5 is also 5 spaces from 0. If instead we were given an equation, absolute value of x equals negative 5, this equation has no solution since distance is never negative. As long as the absolute value expression is isolated, we're just going to take the inside expression 2 minus 4x and set it equal to positive 6 or negative 6. And then just solve each equation individually. Okay, so we'll subtract 2 from each side. We get negative 4x equals 4, and then divide by negative 4. And therefore x is negative 1. And solve the second equation in a similar manner, so we get x equals 2. And then we can do a quick check. The absolute value of 2 minus 4 times negative 1 is equal to the absolute value of 2 plus 4, or the absolute value of 6, which is definitely 6. And then the absolute value of 2 minus 4 times 2 is equal to the absolute value of 2 minus 8, or the absolute value of negative 6, which is also 6.